Welcome to the world of JavaScript arithmetic operations. In this video, we will explore the fundamental mathematical operations that you can perform in JavaScript. Let's start with the basic operators. The plus symbol is used for addition. It adds two numbers together. The minus symbol is for subtraction. It subtracts the second number from the first. The asterisk symbol is used for multiplication, and the forward slash is used for division. Now let's see how we can use these operators in JavaScript. Here we declare two variables x and y with the values 10 and 5 respectively. We can then calculate the sum, difference, product, and quotient using the operators. The sum of x plus y, which is 10 plus 5, is 15. The difference of x minus y, or 10 minus 5, is 5. The product of x multiplied by y, or 10 times 5, is 50. The quotient of x divided by y, or 10 divided by 5, is 2. We can also combine multiple operations together using parenthesis, like x plus y times 2, which results in 30 because the addition within the parenthesis is done first. Now let's explore increment and decrement operators in JavaScript, which are useful for changing the value of a variable by 1. These operators come in two forms: pre and post. Pre-increment, denoted by plus x, increments the value of x before it is used in the expression. Post-increment, denoted by x plus, returns the current value of x and then increments it. Let's look at some examples. In pre-increment, we set a to 5 and then b to plus a. First, the value of a is increment to 6, and then this new value 6 is assigned to b. This results in both a and b being 6. In post-increment, we set x to 5 and then y to x plus. Here the current value of x, which is 5, is assigned to y first, and then x is increment to 6. This gives us x equal to 6 and y equal to 5. When these operators are used in expressions, pre-increment and decrement modify the variable before its value is used, while post-increment and decrement modify the variable after the value is used. In the example, 2 times plus count gives you 4 because count is incremented to first and then it is multiplied by 2. On the other hand, in 2 times count plus it gives you 4 because the current value of count, which is 2, is used first and then count is increment to 3, which you can verify by the next line of the code. Let's talk about floating point precision issues in JavaScript. JavaScript uses a standard called IEEE 754 to represent numbers. This can lead to some unexpected results when doing decimal arithmetic. For example, if you try to add 0.1 and 0.2, you might expect to get 0.3, but instead you get 0.3 followed by a bunch of zeros and a 4 at the end. Similarly, 0.3 minus 0.1 does not give 0.2 exactly, and 1.0 minus 0.9 does not give 0.1 exactly. These happen because of the way that floating point numbers are stored in memory. Fortunately, there are a few ways to work around this. The first is by using the toFixed method. When you use toFixed, you can specify the number of decimal places you want to keep. For example, if you have 0.1 plus 0.2, and you call toFixed with 2, you will get the string 0.30. Another solution is to multiply your decimal numbers by a power of 10, perform your calculations, and then divide the result by the same power of 10. For example, if you multiply 0.1 by 10, 0.2 by 10, add them up, and divide the result by 10, you will get 0.3 exactly. Number.EPSILON can also be used to compare if numbers are equal within a small margin of error. This method is particularly helpful when performing currency calculations. So always use precision handling when dealing with numbers to avoid unexpected issues in your applications. Let's explore the math object in JavaScript. This built-in object provides many useful methods for performing mathematical tasks. Here are some common ones. The math.abs method returns the absolute value of a number. For example, the absolute value of -5 is 5 and the absolute value of 5 is also 5. The math.round method rounds a number to the nearest integer. For example, 4.7 will be rounded to 5 and 4.4 will be rounded to 4. The math.ceil method rounds a number up to the nearest integer, and math.floor rounds a number down to the nearest integer. For example, 4.1 will be rounded to 5 with seal, and 4.9 will be rounded down to 4 with floor. The math.max method returns the largest of the given numbers, and math.min returns the smallest of the given numbers. For example, math.max of 5, 10, and 15 is 15, and math.min of 5, 10, and 15 is 5. Math.pow returns the base to the exponent power, and math.sqrt returns the square root of the given number. For example, 2 to the power of 3 is 8, and the square root of 16 is 4. The method math.random returns a random number between 0 inclusive and 1 exclusive. A useful tip when using random numbers is that to generate a random integer between a minimum and maximum value, you need to use this function. This function returns the random integer within the specified range. Let's explore BigInt operations in JavaScript. BigInt is a special data type that lets you represent whole numbers larger than 2 to the power of 53 minus 1. This is the largest number that JavaScript can handle reliably with the regular number primitive. BigInts are essential when dealing with very large numbers that exceed JavaScript's normal limits. You create a BigInt by appending the letter n to the end of a number literal, or by using the BigInt function. BigInts can only represent integers. They do not allow decimal places. You also cannot mix BigInts with regular numbers in calculations. For example, if you add one n to a BigInt, that's okay, but adding one without the n to a BigInt will result in an error. BigInts are really good for large integer calculations. Here we are creating two BigInts, one using a literal value, and another by passing a string to the BigInt constructor. Basic arithmetic operations like addition, multiplication, and division work the same as with regular numbers. However, when you divide two BigInts, the result is also an integer, and decimal values are truncated. For comparison, the less than, greater than, and strict equality operators work with BigInts, but be careful when using non-strict equals operator with BigInt and number because these can give unexpected results. You can convert a BigInt to a regular number using the number function, and you can convert a number to a BigInt using the BigInt function. Here's a table that highlights key differences between regular numbers and BigInts. When dividing numbers, a number division gives you decimal values, but a BigInt division gives you a BigInt. Also, the type of a regular number is number and the type of a BigInt is BigInt. And finally, regular numbers are limited in size, but BigInts can represent much larger values. Let's discuss some common mathematical algorithms that are frequently used in JavaScript development. We will implement factorial, Fibonacci, prime number checker, and greatest common divisor algorithms. The factorial of a non-negative integer, denoted by n!, is the product of all positive integers less than or equal to n. For example, 5 factorial is 5 times 4 times 3 times 2 times 1, which is equal to 120. Here's a JavaScript function that calculates the factorial of a given number recursively. The Fibonacci sequence is a sequence in which each number is the sum of the two preceding ones. It typically starts with 0 and 1, the next number will be 1, next 2, then 3, 5, 8, and so on. Here's a function that calculates the nth number in the Fibonacci sequence, using an iterative approach. A prime number is a natural number greater than 1 that is not a product of two smaller natural numbers. The first few prime numbers are 2, 3, 5, 7, and so on. Here's a function that checks if a given number is prime, or not by dividing it with numbers up to its square root. Finally, the greatest common divisor of two numbers is the largest number that divides both of them without any remainder. For example, the greatest common divisor of 48 and 18 is 6. Here's a function that implements the Euclidean algorithm to calculate the GCD of two numbers. A useful tip to improve performance is to use memoization, or caching results for frequently called functions with the same parameters, so that you don't have to recalculate them every single time. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.